is basically, as it says, about radians, sectors, unit circle, and solving trick, etc., etc., etc. In terms of the unit circle stuff, I'll start doing some of the unit circle derivation, but then I'm going to revert to the actual results in a second. So essentially, you have, I'll start with the unit circle first. Sorry, that shouldn't say reduction formula. That was for the previous lesson. So this is unit circle. You have unit circle, as it says, is a circle of radius 1 unit. So when you have that, that's radius of 1. So when you're in the first quadrant, you have, this is your x, and this is your y. And of course, when you use the SOHCAHTOA on this right angle triangle, x will be cos theta, and y will be sine theta. Because that's your hypotenuse, that's your opposite, that's your adjacent. And you use the SOHCAHTOA formula, you get basically the that stuff there. So that just goes to show that the tan, by the way, is just going to be that over that, opposite over adjacent, which is then going to be sine over the cos, which is going to be y over the x, basically. So when you move over to the second quadrant, when you are in here, then you have, this is minus x, that's positive y, and that angle then is 180 minus theta. And instead of going through the results again, I'm just going to show you then the summary of all of that. So when you are in the so-called sine quadrant, then what you have then is that you have you in here. That means then your sine 180 minus theta is going to be sine theta, positive. Your cos 180 minus theta is going to be minus cos theta. Your tan 180 minus theta is going to be minus tan theta, using your unit circle. When you are in the quadrant here, the third quadrant, this is the third quadrant, where you're in the tan quadrant, so to speak, then your sine 180 plus theta is going to be minus sine, cos is going to be minus cos, and tan is going to be positive tan. And then when you are over into the last quadrant, the fourth quadrant, C quadrant, then your y is going to be negative, your x is going to be positive, and so your sine 360 minus theta is going to be minus sine, cos 360 minus theta is going to be cos, tan 360 minus theta is going to be minus tan. So that's as far as unit circle is concerned. In terms of then the sector, so I'll use the same one. So sector, in the early years, I think sector looks like that. That's your R, that's your theta, that's your L. That looks like an E, but it's actually an L. If you accept the formula, L then is R theta, where theta is now in radians, is no longer in degrees anymore. And before you freak out, I will explain radians in a second. The area of that is going to be half R squared theta. So the area of that sector is this, and the length is this. Again, theta is in radians. In the earlier years, think as early as year 9, I think L equals theta on 360 times 2 pi r. And the area is also theta over 360 times pi r squared. But these are the days of the degrees, not the radians. Now you're in radians mode. And so without further ado, what is radians? Well, this is what radians is. All right. Radians. Radians is just another measure of angles. But instead of measuring in degrees, you measure in radians. So the whole 360 degrees is the whole circle, but that is defined as 2 pi radians. That is all. So if you divide this in half, that will be then pi, and that will be 180 degrees. You divide that in half again, that will be 90 degrees. You divide that by half again, that will be 45 degrees. If you divide this by 3, you get pi on 3. And so you divide 180 by 3, you get 60 degrees. If you divide this by 6, you have this divided by 6, so that's 30 degrees. So you must know all of these, and you must commit it to a memory. And so that is all there is. This side is radians. This side is degrees. That's all there is to it. It's another measure of radians. Think of it, if you like, the analogy is in temperature, where you have Celsius and Fahrenheit. It's just another measure of temperature. And if you do chemistry, then it will be in Kelvin. And notice that Kelvin is not in degrees. So radians is just another way of measuring angles. Furthermore, definition. 1 radian is 1 rad, is 1 C. So whenever there is no unit next to it, then it's assumed to be in radians. But if there's a degree sign next to it, that is definitely degrees. So make sure if you are meaning to put radians, then you don't put the degree sign. And likewise, if you don't put the degree sign, that means it's in radians. So if you want it to be in degrees, then you better put the degrees there. So, for example, sine of 30 minus A is not the same as sine 30 degrees minus A. That is not the same, because that now is in radians now. So don't be confused with that. So, you know, the complementary result of sine 90 minus A is not the same as sine of 90 minus A in terms of the degrees. So if you don't put the degrees here, that means that this 90 is in radians. So please don't make that rookie mistake of not putting the degree sign when you need it to be there. All right, how do we then solve this trig equations? So e.g., you have sine theta equals a half, and the domain of theta is between 360 and 0. So how do we solve for that? Simple. Theta then is going to be sine inverse of a half. If you know your exact ratios, I've chosen exact ratios, that's going to be 30 degrees. So then you draw where 30 is, which is here. Put all station to China in there. So 30 degrees is there. Where else is sine going to be positive? Well, it's going to be in the second quadrant. So not only is it going to be 30, it's going to be 150 as well. Because sine of 150 is the same as sine of 30 is the same as a half. Because you learned earlier, sine of 180 degrees minus theta is sine theta from previous lesson with the properties of supplementary results. So your answer in this case is that it's going to be in terms of 30 degrees and 150 degrees. How do we translate that into a question that is exactly the same, but this time They want it to be in radians. They don't want it to be in degrees anymore. They want it in radians. So then you do the same. You go, all right, theta then equals going to be sine inverse of a half. But this time, you have to know that 30 degrees then is going to be pi on 6, according to your basic theory up here. And of course, 150 is going to be 5 pi on 6. Which brings me back to your one here. So if you were to, and by the way, the answer then is theta equals pi on 6, 5 pi on 6, that's all. So it's just radians instead of degrees, that's all. So going back to this guy here as well. You already know this basic stuff, but let me add some more basic stuff to this. If you take this away from this, you get 5 pi on 6. And that's going to be 150 degrees, because 180 minus that is 150. If you take this away from that, you get 2 pi on 3. And if you take this away from that, so that away from that, you get 120 degrees. And if you take away 45 degrees from 180 degrees, you get your last one, which is 135 degrees, gives you 3 pi on 4. These are the exact radians measure that you're going to have to commit to the memory. And that's, in a nutshell, is radians, which I push all up here for you to all see. And that's radians, unit circle, solving trig, and the sector all in one. So I'm going to stop recording now for questions.